Electrophilic substitution reaction of aromatic ether. The alkoxy group in the aromatic ether is ortho and para-directing, and it directs all the electrophiles towards the ortho and para position. This can be cleared from the resonance structure of the aromatic ether. In the structure, we can see the oxygen of alkoxy groups contains two lone pair of electrons. One of the lone pair of electrons undergoes delocalization with the benzene ring. Here, the formation of oxygen-carbon double bond takes place due to the lone pair of oxygen. Hence, the oxygen gains positive charge, and one of the pi electrons will get shifted to the ortho position in this manner. And the electrons keeps on delocalizing on ortho position, para position, and ortho position in this manner. So we can say the electron density increases on ortho and para position. Therefore, alkoxy group is ortho and para directing, and the electron density will attract the electron deficient species, which is called as electrophiles. So electrophiles will attack either on the ortho position or on the para position. Thus, we can say that the aromatic ether will give electrophilic substitution reaction. This can be cleared from the following reaction. Halogenation in anisole. Anisole is also called as methoxybenzene. Commonly, it is called as anisole. When anisole reacts with bromine molecule, the bromine molecule can be written as bromine single bond bromine. So the hydrogen of ortho position will combine with one of the bromine molecule to form hydrogen bromide as byproduct, and the second atom of bromine will take the place of hydrogen to form orthobromoanisole. Same thing will happen at the para position to form the para-bromoanisole. And we know among the para and ortho product, para is the major product. Nitration in anisole. Nitration of anisoles takes place when the nitric acid reacts with anisole in the presence of concentrated sulfuric acid. So when the nitric acid can be written as in this manner in order to explain the reaction. So nitric acid, the OH group of nitric acid will combine with the hydrogen of benzene ring of the anisole, para-hydrogen. So to form water molecule as byproduct, since the hydrogen at the para position is replaced by the NO2 group, so it will give para-nitroanisole or 4-nitroanisole. The same reaction will take place at ortho position also. So in this manner, the hydrogen is replaced by the nitro group in the nitration of anisole. Friedel-Crafts reaction of anisole. Friedel-Crafts reactions are of two types. The first type is alkylation reaction. Alkylation reaction is the addition of alkyl group at ortho position and para position, and acylation reaction. The acylation reaction is the introduction of acyl group, RCO group at ortho and para position. The alkylation reaction takes place when the anisole or an aromatic compound reacts with alkyl halide and the ortho and para hydrogen is replaced by the alkyl group. And acylation reaction is the introduction of acyl group, that is RCO group, at ortho and para position when the reaction is done by acyl halide. But this reaction takes place when aluminum chloride is taken as a catalyst. The presence of catalyst is must here, so the catalyst, that is aluminum chloride, helps to catalyze the reaction, and the reaction takes place in the presence of aluminum chloride, which behaves like a Lewis acid, because in the structure of aluminum chloride, aluminum has only 6 electrons. So it is the limitations of, it is the drawback of octet rule. The point to be noted here is that the RCO group is called as acyl group in general. If the alkyl group of RCO is taken as methyl group, then it will be acetyl group. It will be called as acetyl group. So starting with Friedel-Crafts alkylation reaction of anisole, when anisole reacts with methyl chloride in the presence of anhydrous AlCl3, the hydrogen of ortho position will combine with the chlorine of methyl chloride to form hydrogen chloride as byproduct, and the methyl group will take the place of hydrogen to form 2-methoxytoluene. The same process will take place at para position also to form 4-methoxytoluene as the major product. Friedel-Crafts acylation reaction of anisole. Here, when anisole, that is methoxybenzene, react with acetyl chloride, ethanol chloride, in the presence of anhydrous AlCl3, the hydrogen of ortho position will combine with the chlorine of acetyl chloride to form hydrogen chloride as the byproduct, and the remaining group, that is the acetyl group, get added to the ortho position. It will replace the hydrogen to form 2-methoxyacetophenone. The same process will take place at para position also to form 4-methoxyacetophenone. Since the reaction is the acylation, but acetylation is the example of acylation reaction, which I have cleared that if the addition of RCO group takes place, then the reaction will be acylation reaction, and if this can be cleared from the given if the introduction of RCO group takes place, then the reaction is acylation reaction, and if the acetyl group is added, then the reaction will be called as acetylation reaction. So thus we can say that the given reaction is the acetylation reaction, which can be included under acylation reaction.